spinal cord, well, now it can vary because it's going to depend on like height, weight, everything like that of the person. But on average, close to about 2 centimeters. Yeah, it seems like you would think it would be this great big huge object, but in reality, it's not. It's very tiny. It blows my mind. So, in this structure that we see, we're going to find that on that posterior portion, the dorsal side, okay, does everybody remember that term? Okay, we get what's called some dorsal horns on the posterior side. We're going to see on the posterior side, we're going to find that as we have the nerve, we're going to get what looks like a root, like something you would put in the ground to grow, okay? That's a dorsal root, and it's the spinal nerve, and we only have in this area back here, coming on this posterior portion, sensory fibers. So that tells me that spinal nerve that exits on each side, okay, if I'm looking at this, that spinal nerve that exits and comes around to everything else, okay, that the only thing that once the information begins to do this number and we get the split as we get into the bone, okay, it's going to split and all my sensory information goes into the dorsal side. So my sensory information is going into the dorsal side of my spinal cord. Anterior or ventral, we're going to see some horns. So if it's anterior, if dorsal was sensory, the only thing that could be anterior is the motor, the response. So if the sensation came in on the back, the response comes out the front. So dorsal ventral. Now, a couple of other things. We're going to see that we have what's called the gray commissure. Basically a connection between the left and the right. And then on the lateral side of this spinal cord, we get what's called a lateral horn. The lateral portion is strictly for the autonomic nervous system, the one that's going to deal with our organs. So the lateral portion deals only with the organs in the body, the viscera. The anterior and the posterior are dealing with everything else. Does that make sense? I see confusion. When we have the spinal nerves exit, those spinal nerves, we're going to find that there is innervation. Remember, I said to everything else. And everything else means skeletal muscle, smooth muscle, cardiac. When we think of the skeletal muscle, we think of having this ability for all the sensory information to go in. Is that correct? But trust me, there's sensory information from your organs too. but we've got sensory information that needs to go in. So it does, and it goes into the dorsal side. The response, like to kick or get up to move, to start, whatever the case might be, okay, comes out the ventral side. Somewhere needs to pay attention to my organs. That's the lateral side of the spinal cord. Okay? And it works by way of the spinal nerves. But it's just going to viscera of the body. So, we have posterior, anterior, lateral. And that's pretty much covering everything here down. Because I haven't done up here yet. Okay? So it's pretty much covering everything from here down. Now, the white matter that you find, because these are the axons, isn't it the axons that are passing information? Okay? Isn't that how you learned in part 1 that the information traveled the axon? Okay? So, information is moving. So, we're going to have information go up the spinal cord, responses come down. So we end up, those grooves, all those little grooves and everything that I showed you, these are going to make, or they're called columns. Now, somebody got inventive in lab that day, all right, and said, well, why don't we call it funiculi? Okay, why can't we just go with column? I understand that. Anyway, so columns. Think of columns. Woo-hoo, woo-hoo. Okay. 3 pairs. We just talked about the 3 sides. Posterior, anterior, lateral. So I've got some columns that'll go up on the posterior side, some columns that'll go up on the lateral side. Is everybody following me? So I have posterior columns, lateral columns, and anterior, and they're on both sides, left and right. The columns have little tracks, T-R-A-C-T's, okay? Why they couldn't just go with T-R-A-C-K, I don't know, okay? But T-R-A-C-T's. You think of a track, stuff's moving, right? Okay, so stuff's moving. So, ta-da! We end up getting, remember, sensory information comes in one side, motor information the other side, so that tells me that I got to have tracks that take information up and bring motor information down. That one's easy. I got ascending and descending tracks. And that's what they do. They take information up and bring the response down. So for an ascending tract, sensory information, stuff from out here, goes up. The response comes down. Now, I love the next term. The information, for the most part, decussates. And it don't mean you take back something you said to somebody. Okay? Decussation means it crosses sides. You know how we have this idea that people tell us the right brain is the right side's controlling the left is controlling the right? For the most part, yes. Okay? Note my terminology though, for the most part. And some of our reflexes, okay, some of our reflexes are not that way. Okay? Some of that information doesn't cross sides. It stays on one side. This is the reason that if people have a brain injury or a stroke or something along those lines, and it's on, say, the right side of their brain, the left side of their body is affected. Because for the most part, information decussates. So that is, for the most part, what happens. When we have something where the origin and the destination are on opposite sides of the body, we say that's contralateral. Like if something happened here, but everything ended up with a response and everything on one side, we would say, even though it happened here, it affected here, it's contra. Contra means on the other side. Okay? If it stays on one side, like if an injury or something happened, and it happened on this side, and the result was on this side, it's ipsa, because that stays on the same side. Now, a lot of that deals with reflexes that we get in our body. Now, when we have information that has to go in, our sensory information, the way that that information is going to move. Now, let's stop and think about this for a second. Let's use an example, okay? It's telling me that my sensory information travels across 3 neurons. What does that mean? All right, let's think about this for a second. Okay, so it, all right, decides to lean on the table. All right, one of the biggest things that it is recognizing is pressure. All right, so that tells me, and do you guys remember where pressure receptors are in your skin? Okay, so that tells me that the pressure receptors got that sensation. And for it to be recognized by it right here, that means the receptor was in the skin. That was my first neuron. Does that make sense? Now, that traveled all the way to his spinal cord, where that information synapsed. That was my second neuron. That information ascended by way of the tracks up to his brain, where it got recognized. My third neuron. Does that make sense? So sensory information, for the most part, travels in this fashion. A first neuron, second neuron, and a third. All right? So, that third order neuron, what we're going to find is that one, when it gets started, okay, there's going to be an area of your brain for dealing with sensory information and making sure it gets to the correct lobe. What are the lobes of your brain?
The frontal.
Frontal? Temporal, occipital, parietal. Think about it for a second. Temporal is close to my ears, so I know I got to deal with sensation of hearing. Well, occipital is pretty much self-explanatory, okay? Eyes, all right? One of the biggest areas of the brain that's going to be dealing with something such as like skeletal muscle and everything is going to be your frontal, okay? We're going to see that this huge thing up here in the head, all right, does a lot of stuff. But still, the spinal cord does too. So it's going to travel this direction, this way. Now, one of the things about these ascending tracks, your text is going to talk to you a lot about gracile, cuneate, spinothalamic, spinoreticular, blah, blah, blah. If we were going to be going into neurology, neuroscience, whatever the case might be, I would be expecting you to understand every bit of this. I'm going to try to condense it down. What it's telling you, okay, is we're going to have a point of origin for information, and that's letting you know where something starts and ends. My purpose for the tracks for you guys, my purpose is that you all are understanding that I've got ascending tracks, and that is my sensory information. And I have to travel by 3 neurons. Is everybody with me? And then I'm going to have descending tracks, which bring out my response. I want you to understand that we've got them, okay, that we're going to see, because your textbook is going to talk about all of them in detail. But ascending tracks are sensory information.
What was that last little bit that you said about ascending tracks? You said it's the sensory and then...
And then my descending...
No, not the descending. It was like another
Travels by 3 neurons.
Oh, travels by 3 neurons. All right? Now, your textbook goes into great detail. Look what it tells you. Okay? Keep it condensed and short. All right? Read over them. Become familiar with the information. Okay? But I'm not expecting you to come out of here telling, oh, well, guess what? My gracile fasciculus is an ascending tract, and it's going to do blah, blah, blah. No. Okay? So I'm trying to keep it condensed. The reason that I've got this one up here is because of this right here. My gracile fasciculus, proprioception. This is a part of the sensory information that is traveling the gracile fasciculus. What is proprioception?
Non-visual sense.
What does that mean? Your place in space. It's the way that your body is aware of your position. If you're sitting, standing, twirling, tumbling, whatever the case might be, this is how your body is aware of your place in space and lets everything else about you adjust. Your sight, your hearing, your equilibrium, everything. So proprioception is with the gracile, okay? But one of the cool things about it, that's your place in space. We're going to stop right there for today. Tuesday, I think if you check Blackboard, you'll see that the homework for Chapter 13 for Connect is posted. And if I'm not mistaken, I think I have it through next week. So you've got until, I think, September the 3rd to get that done.